safety standards don't exist and/or safety standards would stifle innovation if used. Truth or myth? Both of these are myths. Let's start out with the fact that safety standards for autonomous and automated vehicles do actually exist. There's more standards being created to be sure, but there's a basic core of standards that exist and can be used right now. Let's take a quick tour through them. First, there's the Federal Motor Vehicle Safety Standard and the New Car Assessment Program, NCAP. FMVSS and NCAP are existing standards that apply to ordinary everyday cars. Those also apply to autonomous vehicles. The brakes have to work, the airbags have to work, crash safety has to be there, and so on. So those don't go away. There are also cybersecurity standards, SAJ 3061 and 21434, that apply to computer security for all cars, and they apply to automated and autonomous vehicles as well. There's a functional safety standard, ISO 26262, again, originally developed for conventional cars, but they apply to all cars. Functional safety is functional safety. If your brake computer fails, you have to have a plan for that, and it doesn't matter who's driving, whether it's a computer or a person. The brakes still have to work. Then there's the dynamic driving task, ISO 21448, otherwise called safety of the intended function, and there's some other standards existing and under development that deal with whether or not the driving task itself is safe. These originally started for automated steering control for supervised automation, but they're now extending their scope to include autonomous vehicles as well. These standards have been out for a while too. And then there's ANSI UL 4600, which is a standard specifically designed for autonomous cars at first, and then the third edition does autonomous heavy trucks as well. So this entire stack of standards can apply to any autonomous vehicle. On top of that, ANSI UL 4600 talks about how to organize a safety case to demonstrate that you're safe. And there's another standard, SAJ 3018, which is specifically about road testing safety drivers. All these standards exist. All of them are applicable to any autonomous vehicle out on the road right now. Right now, only FMVSS and NCAP are required. The rest are optional, and there are few, if any, companies that claim they're following most or all of these. Well, why wouldn't companies follow those standards that, by the way, those are industry standards. Industry folks wrote them. Industry folks voted on them. Those are industry standards. Why would they not follow standards? Well, the typical reason is that somehow they don't apply, but that's just not true. Or that somehow they're going to stifle innovation. Oh, we can't follow standards and regulations because they will stifle innovation. You've heard that so many times. Well, let's look at the reality of that claim. Do safety standards mandate particular technology? No, they don't. They require using engineering rigor to show safety the same as safety is done in other industries. They don't say you have to use a LiDAR, and they do not say your LiDAR has to look so far. What they say is you're going to have a plan for what sensors you're going to use. You're going to have to show that the sensors can see what they need to see, and you have to have a plan for what happens when one of the sensor fails. That's pretty much where the standards go. And if you don't have those plans, then you're probably not safe. Another claim is that safety standards limit the ability to test prototypes. No, we can't test, we can't innovate because the standards are tying our hands behind our back. Well, that's not true either. Those standards apply to public road deployments of the technology. They do not apply, with one exception, to road testing. The one exception is J3018, which is not about the technology at all. It's about making sure your test drivers are trained. Do the safety standards limit ability to road test? Well, yeah, J3018, if you conform to it, says that you should use trained safety drivers, not retail customers, but trained drivers. And it says you should have test plans so you actually know what you're doing with testing and you have an organized approach. If you're not doing either one of those, you're not really testing safely. You're just messing around on roads. And they also, if you use ISO 26262, that will tell you that the big red button to turn off the autonomy has to really work when you press it. I've seen that be a problem. Following that standard is a good thing. It's not particularly onerous because you're just talking about the ability to turn off the autonomy. It's not actually covering the autonomy itself. So that's not a lot of limited ability to road test, and probably that's a really good thing to keep the road testing safe. The burden from following safety standards when you're testing innovation approaches is minimal. There can be exemptions for FMVSS, NCAP doesn't apply until you produce a car, and so on. Really, there's nothing in these standards that gets in the way of testing and demonstrating and proving in an engineering sense that your innovation is going to be ready for deployment. Then there's a lot of work to make it safe, but if you're going to sell cars to the general public, yeah, you really need to be safe. And every other industry follows their own standards to get safety. The car industry should do that as well. It's important to remember that when you take out the safety driver, that's not testing anymore. That's deployment. It may be a pilot deployment, it may be a limited scale deployment, but you're putting a machine on public roads that can put other road users at risk. That's a deployment. As a case study in understanding why safety folks generally think about it this way, let's look at the loss of the Titan submersible. There was a catastrophic implosion of this submersible with a loss of 5 people aboard in 2023. This submersible, unlike other submersibles which are made out of metal, was made out of composite materials. It had unorthodox construction techniques and did not submit the design to external reviews. Well, why did they not follow the usual safety practices? Well, the developer had an attitude that real-world testing is the only thing that matters and that regulation kills innovation. These are the two things you kind of hear from the autonomous vehicle crowd, that without real-world testing, you don't know what the answer is, and that we can't have regulation and we can't have standards conformance because that'll kill innovation. And here's what the founder of the company who perished during the implosion said, that real-world testing is what you need. Having an outside entity brought in, sort of a regulator or an independent assessor, is anathema to rapid innovation. So that's why they didn't have outside eyes. And that the commercial sub-industry had not innovated because they have all these regulations. Well, it turns out that if you have regulations and you have outside checks and balances, that isn't really going to impede innovation of tests. It will impede deploying unsafe systems with people other than the developers put at risk, which is what happened here. 5 people died, 4 of them were passengers. The takeaway is, safety standards exist to deter unsafe innovation. That's not the same as deterring innovation. You can innovate all you want in the engineering side of things, but when you're deploying and imposing risk on other road users, you need to be following the safety standards to make sure you're not putting other road users at undue risk.